Hello, my dear students. This is Mr. Shaima Gharib and today's lesson about number sequences. Let's start by revising some rules before you watch any video. You have to sit in a quiet place. You should have your pen and a piece of paper to take notes and to solve questions. You should pause the video after each question, then you try to answer on your own. Then you play the video to check your answer and to understand the question in case you get a wrong answer. Are you ready? Let's start. Number sequence. Any sequence consists of a number of terms, and each term has a position. Let's see by example. This sequence here, it has some numbers as you can see. Each number in this sequence is called a term, and each term or each number in this sequence has a position. For example, 5 is the first term of this number sequence. What is the second term in this number sequence? It will be 10. What about the third term? It will be 15. What about the fourth term? It will be 20, and so on. Okay? And this is the position of each term. So the position of the first term, which is 5, is the first position or 1. 10 is the second term and its position is second. 15 is the third term and its position is third or 3. So now do you know the difference between the term and the position? Let's see. We have a table here. We put all the terms, as you can see, the numbers in the sequence 5, 10, 15, 20, 25, and 30. Now we are going to put the positions of each term in this sequence. So 5 has the first position, 10 the second, 15 the third, and 20 the fourth, and 25 is the fifth, and 30 is the sixth. So now do you know the difference between the position and the term? Okay. Now let's talk about the term-to-term rule. The term-to-term rule is a rule that describes the number sequence by telling what are the changes that happen from term to another in order. Let's see by example. Look at this number sequence. So we said term to term. So from its name, it's from term to another. So what are the changes that happened here? The 5 became 10. What happened? Either to be multiplied by 2 or adding 5. So now let's check from the 10 to the 15, or from the second term to the third term. What happened? It's adding 5, which means every time, or the term-to-term rule, we are adding 5. So when I describe this sequence by telling the term-to-term rule, I'm going to say adding 5 or plus 5. Okay? Now another sequence. 35, which is the first term, became 32. It's going backward, which means subtraction. What happened? We subtracted 3. I'm going to check from the second term to the third term. What happened? 32 became 29. It's subtracting 3 as well, which means when I describe this sequence, I can say subtracting 3 or minus 3, or going backward by 3. Okay, so this is the term-to-term rule, the changes that happen from term to another. Okay, now look at this sequence. It has something different. Look at these numbers: 1, then 4, then 9, then 16. What's going on in this sequence? Do you know these numbers? Actually, these numbers has a description. So if you can find a rule between the numbers, it's okay, but we can describe it in a different way. These numbers are the square numbers. So we can describe a sequence of square numbers by just telling it is square numbers. Is this clear? Now let's talk about another rule, which is position to term rule. We talked about the term to term rule. Now we are going to talk about position to term rule. From its name, it is a rule about the position and the term that connects the position to the term, or to find the relation between the position to the term. Let's see example. We have the positions here in this table and the terms, as you can see. Let's put the positions. So 1, 2, 3, or first, second, third, fourth, fifth, and sixth. And now let's check. Is there any link between the position and the term? Let's see, for example, 1 became 5. So what happened to the 1 to be 5? I can say I added 4, or I multiplied the 1 by 5. So if I added 4 to the 1, it will be 5. Or if I multiply the 1 by 5, it will give me 5. Now let's check which one is the position to the term rule. How? By checking the second term in the sequence. I have number 2 and number 10. 2 became 10. What happened? Did I add it 4? Same as the first one? No. I multiply by 5. So when you multiply the 2 by 5, you will get 10. And here, when I multiplied the 1 by 5, I get 5. So let's check the rest. 3 multiplied by 5 will give me 15. 4 multiplied by 5, 20, and so on. So we can say that the position to term rule is a rule that links the position to the term of the sequence. And in this sequence, the position to term rule is multiply the position by 5 to get the term. So if we multiply the position by 5, any position by 5, we'll get the number in this term, okay? So if I asked you this question, what is the 41st term in this sequence? Am I going to count on by 5 41 times? No. If I know the position to term rule, it will help me to get any term in the sequence that I want. So I know that the position to term rule of this sequence is multiply the position by 5 to get the term. And the 41 is the position. So if I multiplied the 41 by 5, I will get the 41st term in this sequence, which is 205. Is this clear? Now let's move on. Look at these two sequences. Complete the sequence, then write the term to term rule. We have decimal numbers here. Look at the first sequence. What's going on in this sequence? 1.7 became 1.4. What happened? We subtracted 3/10 or 0.3. What happened between the 1.4 became 1.1? We subtracted 0.3. So this sequence, or the term to term rule for this sequence, is subtracting 3/10 or minus 3/10 or minus 0.3. So I need to get the next term in this sequence by subtracting 3/10. When you go back in tenths, or you count back by tenths, starting from the 1.1, let's count backward together. 1.1, then 1, then 0.9, then 0.8. So I counted by tens 3 times. When you count back by tens 3 times, or 3 tens backward, you will get 0.5. Is this clear? Or 5 tenths. Now let's try another sequence here. 0.5 became 0.3. What happened? We subtracted 2 tenths this time. Then 2 more tenths. So what will happen when we subtract 2 tenths from 0.1? Let's count back by tenths starting from 0.1. When you go backward by 1 tenth starting from 0.1, you will get 0. Then, what do you think? Negative 0.1. Is this clear? Now we're going to subtract 2 tenths more. So from negative 0.1, I have negative 0.2, then negative 0.3. So it's really important to know how we can count backward using tenths this way as we did. Now more examples on sequence. The first one, 5, 10, which means I added 5, then 15. So it's very clear it will be 20, then 25. So the term-to-term rule for this sequence is adding 5. Now look at this sequence. It has a decimal number, 2.6, then 2.7. So every time I add 1 tenth, 0.1. So 2.7 plus 0.1, it will be 2.8. So you keep counting by tenths. So after 2.8, we will get 2.9. Then, what do you think? 1 tenth more, 2.9, it will be 3. And if I wanted to keep counting, the next term after the 3 will be 3.1, 3.2, 3.3, up to 3.9, then 4. Is this clear? Now let's try more examples. 3.96. Now look at these numbers. It has 2 decimal places. Let's check what's going on in this sequence. 3.96 became 3.97, which means every time I add 1/100ths. The previous examples, we counted on and back by tenths. In these 2 examples, we are going to count by hundredths. So after 3/97 it will be 3/98. What about what the number after this? By adding 1 more hundredths, so it will be 3/99. If I added 1 more hundredths to this number, what do you think? Which number will be coming here? It will be 4. Then, what after 4? 4/100, which is 4.01. Then 4/200 and 300, 0.4, 4.05, 4.06, 7, and so on up to 0.909. Then 4.10, then 4.11, then 4.12. Okay, up to 4.99, then the one comes after this is number 5. Then you start over counting by 1/100ths every time. Is this clear? Now, let's check the second one. 6.75 or 6/75 became 7. So what's happened in this sequence? We added, of course we added. We added how much? 25 hundredths every time. So when I add 25 hundredths, it will be 7.25. So when I add one more 25 hundredths, I will get 7 and 50 hundredths, or 7.5 we said before. They are the same. So I can write it as 7.50 or 7.5. Is this okay? Now, if I added more 0.25, and as we said, this one same as 7 and 50 hundredths. So when you add 25 to the 50 hundredths, they will be 75 hundredths. So it will be 7 and 75 hundredths. What about the next one? When I add 25 hundredths more, it will be 7 and 100 hundredths, which means, with the meaning of 100 hundredths, it means one whole, so the number will be number 8. Is this clear? Now, different sequences, but this time we're using fractions. 0, then 1/4, which means I added only 1/4. 1/4, then 2/4, then 3/4, means every time I add 1/4, it is 1/4 more. So after 3/4, we have 4/4. With the meaning of 4/4, one whole. So after one whole, if I added one more quarter, I'll be having 1 and 1/4, which is a mixed number. Okay? So now let's try the next one. 4 and 1/3, then 4 and 2/3. So it seems that we're adding 1/3 every time. If I have 4 and 2/3, and I'm going to add one more third, it will be 4 and 3/3, which is 3/3, which is one whole, which means this 5 here. The 4 will be 5. After the 5, when I add one more third, it will be 5 and 1/3. Add one more third, it will be 5 and 2/3. If I want to add one more third to this term, it will be 5 and 3/3, which is, what do you think? Which is number 6. Then 6 and 1/3, 6 2/3, then 7, 7 1/3, 7 2/3, 8, and so on. Okay? It's really important to know how you can count forward and backward by unit fractions, such as quarter, third, fifths, whatever the fraction is. Okay? Is this clear? Now look at this sequence. 2/5 became 3/5. 11 and 2/5, 11 and 3/5. So we added 1/5. And here 3/5 became 4/5. So we added 1/5. So when you add one more fifth to the 11 and 4/5, it will be 11 and 5/5, which is number 12. Okay? Now, if I added 1/5 to the 12, it will be 12 and 1/5. Then one more fifth, so it will be 12 and 2/5. If I want to continue, it will be 12 3/5, 12 4/5, then 12 5/5, which is 13. We will not write it 12 5/5. We are going to write 13. Then we start over. 13 and 1/5, 13 2/5, 13 3/5, 13 4/5, and 14, and so on. Okay? So please study this well and keep practicing counting on and back by unit fractions such as 1/3, 1/4, 1/2, 1/5, 1/6, 1/7, 1/8, and so on. Now look at these three sequences. We are going to complete the sequence, then we are going to write the term-to-term rule. 62,129, 62,130. So it seems that I added one here. Let's check the next two terms. So from 62,130 to 62,132. So I added 2. Look what happened here. So I added 1, then I added 2. What do you think? What should I add the next time? If the sequence goes this way, +1, +2, so the coming term-to-term will be adding 3. So when I add 3 to this number, it will be 62,135. So the next will be adding 4. So when I add 4 to this number, it will be 62,139. And the term-to-term rule here is adding 1, then 2, then 3, then 4, and so on. Okay? Now, let's check the second one. 940,334, 940,338. What happened? I added 4. And I have a missing term. Don't continue as adding 4 until you check what's going on or the relation between all the terms. So I will go to these two terms and check what's going on here. 940,358 became 374. Is it adding 4? No. So what happened between these two terms? Adding 16. So I started the sequence by adding 4, then here we added 16. So I need to find out what's going on in this sequence. Let's see. We have here a jump, then another jump from this term to this term. So now I started with 4, then, and here I ended by adding 16. What do you think? What's going on here? Am I adding by 1? So +4, then +5, then +6, then +16? No. Am I adding by 2? +4, +6, +8, then it should be +10. So it's not by 2. But it's so clear that we're adding by 4 or multiples of 4. I added 4, then I will add 8, then I will get this number here, 940,346. Then I'm going to add 12. So it's 4, 8, 12, 16. Now it does make a sequence. It does make a pattern. Okay? To get this number, is it correct? Yes. When I add 12 to this number, I will get this number. When I add 16. So what do you think? What should I add here? 4, 8, 12, 16. Then the coming one will be 20. So when you add 20 to this number, you will get this number here, 940,394. Now let's check the last one. So the term-to-term rule for this sequence is adding multiples of 4. 4, 8, 12, 16, 20 means multiples of 4. So I add multiples of 4. Now let's check the next sequence. I have these two terms. So I will check, I will start from here to know what's going on in this sequence. 698 became 691. So I subtracted 7. Let's check the next two terms. 152,691 became 152,683. So the 91 became 83. What happened? I subtracted 8. Oh, what's going on in this sequence? -7, -8. So what about the next one? What do you think? It should be -9. So when I subtract a 9 from this number, It will be 152,674. Now, if I want to get the missing number here, we know that this is minus 7, minus 8, minus 9. So what do you think? How to get this number here? If I subtracted what from this number? So if this is minus 7, so the one before it will be minus 6, and this one will be minus 5. So if I subtracted 5, then 6, then 7, then 8, then 9, so this sequence will be correct. Now let's start subtracting 5 from the sequence. So I will get 152,704. Is this clear? So we can say the term-to-term rule for this sequence is subtracting 5, then 6, then 7, and so on. Is this clear? Now look at these two sequences. Let's check what happened. 42,300, then 52,300. So we added 10,000. What about the next two terms? 52,000 became 62,000. So I added 10,000, which means I'm going to add 10,000 each time. So it will be 72,300, then 82,300. Now let's go to the next one. 38,287 became 38,280, which means I subtracted 7. Let's check the next two. 280 became 273, which means I subtracted 7. So it will continue the same way. I will subtract 7 every time. So it will be 38,266. Then when I subtract 7, it will be 38,259. Now look at this sequence: 4, 8, 12, 16. Okay, and then two missing numbers. Let's see, what is the term-to-term rule? From the 4 to be 8, we added 4. Then we added more 4 to get the 12. Then we add 4 more to get the 16. Which means the term-to-term rule is adding 4. Let's see the next question. What is the position-to-term rule? Here, I'm going to use the pen to show or to write the positions. What is the position of the 4 is 1. And for the 8 is 2. And for the 12 is 3, because 4 is the first term in the sequence. 8 is the second term in the sequence. 12 is the third term in the sequence, and so on. So the 16 will be the fourth term in the sequence. We said the position-to-term rule is a rule that connects the position with the term. It connects the position with the term. Okay, so the 1 became 4, what happened? The 2 became 8, what happened? And it has to be the same rule with all the positions with the opposite terms. Okay, so the 1 to be 4, either to add 3 or multiply by 4. What happened here? 2 became 8, so it is multiplied by 4. So 1 times 4 gives 4, 2 times 4 gives 8, 3 times 4 gives 12, 4 times 4 gives 16. Which means the position-to-term rule is multiplying by 4. We multiply the position by 4 to get the term in the sequence. Now, could 58 be in this sequence? What do you think? Look at these numbers. What are these numbers? 4, 8, 12, 16. They are multiples of 4, right? So any number in this sequence must be a multiple of 4. Is 58 a multiple of 4? No. How do we check? We just divide it by 4. How we divide by 4? Find the half twice. If the number can be halved twice, so it is divisible by 4. What is half of 58? 8. Half 50 is 25. Half 8 is 4. So half 58 is 29. Is 29 can be halved one more time? No, of course, because it's an odd number, so there will be remainder. So this number is not divisible by 4 and it's not a multiple of 4. So could 58 be in this sequence? No, because 58 is not divisible by 4 and it's not multiple of 4. Okay? Is this clear? What is the 70th term in this sequence? Am I going to count on by 4 70 times? No, I know the position to term rule, which means multiply the position by 4. If you multiply the position by 4, you will get the term. So the position here is 70. So if I multiply the 70 by 4, I will get the 70th term in this sequence, which is 280. Now, let's see another example. The following number sequence starts at 1.5. It goes backward by subtracting 0.3 every time. So, let's complete the missing numbers in this sequence. So, it is starting with 1.5 and it goes backward by subtracting 0.3 every time. So when I subtract the 0.3 from the 1.5, it will give me 1.2. Then subtract 3/10 more, it will be 0.9. More will be 0.6. Then 0.3. Now, what is the term-to-term rule? It is subtracting 0.3 or 3/10. Okay. What is the first negative number in this sequence? So if we keep subtracting 0.3 every time, let's see what we will get. What is the next term after the 0.3 here? When you subtract the 0.3, it will give you 0. So this will be the next term. Then when you subtract 0.3 from the 0, or when you go back 3/10 starting from the 0, you will get negative 0.3. Why? Negative 0.1, negative 0.2, and then negative 0.3. Okay? Is this clear? What is the 10th term in this sequence? We already have 1, 2, 3, 4, 5, 6, 7. If we continue counting backward, we will get negative 0.6, then negative 0.9, right? Is it the 10th term yet? No, one more. Then, what do you think? Negative 0. Or, is it 0 point something? No, it will be negative 1 point. What do you think? Yes, 2. Okay, is this clear? And now it's our questions time. Complete then tell which numbers property is represented by the following sequences: 4, 9, 16, 25, 36, 49, and 1, 3, 6, 10, 15, and 2, 3, 5, 7, and 1, 8, 27. I want you to look at these numbers. These numbers are special numbers. So please tell which numbers property and try to complete the sequence each time. Okay, now let's start. 4, 9, 16, 25, they are square numbers. So after the 49, we are going to square the 8, which is 64, then 81, then 100. And the property represented is square numbers. 1, 3, 6, 10, 15. We added 2, then we added 3, then we added 4, then we added 5, so we will add 6, then we will add 7, then we will add 8. What are these numbers? Triangular numbers. 2, 3, 5, 7. What do you think? We added 1, then we added 2, then we added 2 one more time. It does not look like a sequence. So if this is 11, what are these numbers? Are prime numbers. So 2, 3, 5, 7, then 11, 13, and 17. So these numbers are prime numbers. Sequence of prime numbers. Now what about these numbers? 1, 8, then 27. So what do you think? 1, then 8, then 27. They are cube numbers. So this will be 64, which is 4 cubed, and 125, which is 5 cubed, and then 216, which is 6 cubed. And the property here is cube numbers. Now look at this sequence. The first one, what's going on? We added, or we subtracted. The 940,000 became 840,000. So we subtracted 100,000. We are going to check the next two terms. It's also subtracting 100,000. So I'm going to subtract 100,000 each time. So it will be 640,610, then 540,610. The second sequence, let's check what's going on here. It seems adding. The numbers increases, so it's adding 9. As you can see, 361 became 370. And the second two terms, 370 became 379, so we added 9 as well. So it will continue the same way. By adding 9, I will get 187,388. Then add one more 9, so you will get 187,397. Now look at this sequence, 3, 6, 9, 12. What is the term-to-term rule? The 3 became 6, which means add 3, then add 3, then add 3. So the term-to-term rule is adding 3. What is the position-to-term rule? Let's see the positions. We said 3 in the first position, 6 in the 2, 9 in the third, and 12 is in the fourth. So the 1 became 3, it is multiplied by 3. The 2 became 6, it is multiplied by 6. By 3, sorry. 3 became 9, multiplied by 3 as well. So when you multiply the position by 3, you will get the term, which means the position to term rule is multiplying by 3. Could 156 be in this sequence? Look at this sequence. It shows multiples of 3, right? 3, 6, 9, 12. So the coming one will be 15, then 18. These are the multiples of 3. So I'm going to check, is 156 a multiple of 3? How to check? By adding the digits. 1 plus 5 is 6. Plus 6, 12. Is 12 a multiple of 3? Yes. So this number, 156, will be a multiple of 3 as well, and it will be in this sequence. Yes, because 156 is a multiple of 3. What is the 100th term in this sequence? We know that the position to term rule is multiplying the position by 3 to get the term. So if I multiplied the 100 by 3, it will give me 300, which is the 100th term in this sequence. Now, look at this table. It has positions and terms for a sequence. The sequence is 11, 12, 13. And then I have a missing position here, and this is the 50th position and then the 100th position. So what is the term-to-term rule? We can tell 11, then 12, then 13. I will not say 32 because I don't know if this 32 is the fourth term or not. Okay, so the term-to-term rule is adding 1. The 11 became 12, and 12 became 13. So it's very clear to me now. What is the position to term rule? 1 became 11, 2 became 12, 3 became 13. What do you think? Every time I add 10. 1 plus 10 gives 11, 2 plus 10 gives 12, 3 plus 10 gives 13. So the position to term rule is adding 10. Now complete the table. If I know that the position is 50, so to get the term in the 50th position, I'm going to add 10 to the position. And to get the term here, I'm going to add 10 to the 100. Then the numbers will be 50 plus 10 gives 60, 100 plus 10 gives 110. But in this place, I miss the position. So I need to go backward, which means I'm going to subtract 10 to get the position. So when you subtract 10 from the 32, you will get 22. What is the 41st term in this sequence? We said that position to term rule is adding 10. So I'm going to add 10 to the position to get the term. So 41 plus 10 equals 51. So the 41st term in this sequence will be 51. This is the end of our lesson today. I hope you enjoyed the video, and if you have any question, please feel free to leave a comment and I will answer you as soon as possible. Please remember that your feedback is highly appreciated. Thank you very much and have a nice day.